Dear students, welcome to another math session. We'll continue our topic of vectors. Today it's the last topic in vector known as position vector. Before start our discussion about position vector, let us have a quick recap what we have covered so far in vectors. So first of all, vectors, you know the definition of vector is that these are physical quantities which can be described by magnitude and direction. Okay, and these can be represented by a straight line with an arrowhead at one end. You can name them as, for example, AB, or using small letters, say vector A. Okay, so we can add, we have two vectors, we can subtract two vectors by using simple rules, and we also discussed that if you add the vectors A and B, so order doesn't matter, you can add them in any order, your resultant remains the same. But if you subtract them, A minus B, then B minus A, these are not equal. We also have discussed multiplication of a vector by a scalar quantity. Scalar mean by a number, for example. Okay, so if we have a vector A and we multiply it by 2, so that will end up in a vector 2A, which is in the same direction but double in magnitude as compared to vector A. You can also multiply a vector by a negative number, for example minus 2. So this is minus 2A. Still it is a parallel vector to A, but its direction is opposite to vector A, and because it is multiplied by 2, so the length will be increased. It has twice the length as of vector A. Then there was a topic of column vectors, and column vectors basically represent the displacement of a vector along x and y direction. The first number at the top, that represent the displacement along x-axis, and the second represents the displacement along y-axis. So for example, if a vector is represented by 3 and 2, so it means that we can start anywhere on the graph paper and then move 3 units toward right, because this is positive 3, so 3 units along x-axis to the right side, and then 2 units upward along the y-axis. So that will be the final point. So if you join these two lines, that would be our required vector 3, 2. So we already have discussed this one in detail. Then there was a concept of parallel vectors. So as you can see here, if vectors are multiples of each other, they are always parallel to each other. You can figure out parallel vector not only from the diagrams, but also from the column vector. So for example, if vector A is given by 3, 2, and another vector B, say for example, is given by 6, 4, clearly if you multiply vector A by 2, you will get vector B. So these are multiples of each other. So vector A and B are parallel to each other. And the last thing which we discussed in the previous session was modulus of a vector. Modulus basically gives you the magnitude or the length of a vector. Because length is always positive, so we use modulus. Modulus gives you a positive value at the end. And to work out the modulus, if you have a vector A represented by x and y displacement, then mod of A or modulus of A is equal to x square plus y square under the root. So that was a quick recap what we have covered by now in the topic of vectors. Our topic for today is position vector. So position vectors are also simple vectors, and all of the above operation which we have discussed also are true in case of position vectors. So let us have a look into the set of axes where this is the origin O. And if I draw a vector from the origin and say this is my vector, this is my point O, this is point A. So there is a vector OA which is basically starting from the origin. So whenever a vector starts from the origin, that is called position vector. So OA is a position vector, right? Similarly, if you draw another one here, say for example, this is B. So OB is a position vector. If you draw another one in another direction, see this is C. OC is also a position vector. So because all these vectors are originated from the origin of this set of axes, therefore they are known as position vectors. Position vectors are very useful. You will learn more about position vector in the higher classes. Here we will just see how we can use position vector in sorting out some other vectors in terms of position vectors. And so normally the position vector OA is normally represented by A, position vector OB is represented by B, and position vector OC is represented by C. So in the next video, I'm going to work out a couple of questions for you, explaining further about position vectors.